Hi everyone. So today we're doing an introduction to titrations. So pretty much the rest of our um, content for this module is going to be about titrations. Now titrations are very important. They're a very precise method of volumetric analysis. Normally we run a titration competition, hoping to this year again. But it's not being run by RACI this year, so we're going to have to run it ourselves, but we'll see how we go. Anyway, here's an introduction. Our syllabus outcome is conduct practical investigations to analyze the concentration of an unknown acid or base by titration. So here's our revision. Buffers are chemical systems that resist pH change. They're made of a weak acid and its conjugate base, or a weak base and its conjugate acid. Any introduced acid reacts with any base to neutralize it, and conjugate base reacts with any introduced acid to neutralize it. Okay, so we have that system of acid, conjugate base. One will react with an acid, one will react with a base, resist that pH change. Now, a titration. It's defined as the process of determining the quantity of a substance A by adding measured increments of substance B, which we call the titrant, with which it reacts until an exact chemical equivalence is achieved, and we call this the equivalence point. Titration is a form of quantitative analysis, so it's all to do with numbers, it's not qualitative. It's a technique that uses mathematical and statistical modeling, measurement, and research to understand the behavior. In particular, we call it volumetric analysis. In other words, metric, which meaning to measure, and volume is a measure of 3D space. So we're looking at the volumes of liquids and seeing how they react. The point of titrations is generally to determine the concentration of a compound in solution. It can be extended to, analyze certain compounds in solid samples by dissolving them and reacting the compounds from that. We do that by accurately measuring the volume of certain solutions. So here's some of the equipment we're going to be using. Some of it you might have seen before, but we're going to have to get very good at using all of this equipment. So firstly, the burettes. So these are long tubes that hold generally 25 or 50 mils of liquid. They've got a stopcock at the bottom, which allows you to let liquid through. And the divisions on the side measure to every 0.1 milliliter. And they're so far spaced out that if you look closely, you can actually estimate it down to at least 0.02 mils. Okay, and so that lets us accurately calculate a variable amount of liquid that was added to a titration. We also have volumetric pipettes. So these ones I know you guys have definitely used before. A volumetric pipette or a bulb pipette, they're used for extreme accurate measurements of a fixed volume of solution. Okay, it's always going to be fixed, and that fixed volume is actually there on the side. So you can see that here in this picture we've got a 1 mil, 2 mil, 5 mil, and 10 mil. Now we can see if we fill it properly, it's only going to have a variance of 0.02 mils for that 10 mil volumetric pipette. So if we do it right, then it should be 10 plus or minus 0.02 mils. We also have a graduated pipette. Now I know you use this for your last assessment. They're not quite as accurate as the fixed volumes, but fixed volumes only come in 1, 2, 5, 10, 25 mils. These ones can get down to 0.1 mils for many different volumes. Okay, like I said, they're a bit less accurate, but they're more flexible in terms of the amount of stuff that you need to dispense. We also have volumetric flasks. Now, similar to our volumetric pipettes, they allow solutions to be made from known masses of reagents, and it allows us to create a standard. So basically we know the volume, we know how much stuff that we put in, and we can from that calculate a concentration. Now, reading volumetric glassware. Something that I haven't really taught you so far is how to properly use the volumetric and graduated pipettes to do reading, like how to read them properly. Now, with this volumetric glassware, it always involves the meniscus of the liquid. Okay. Now, the meniscus is the upwards or downwards curvature of a liquid due to surface tension. So here we can see that we've got just a normal liquid, normal water sort of liquid. We can see that the edge turns up. Okay. So that's the meniscus, that shape there. And we can see here we've got a sample of mercury, which is one of the few that has a downwards meniscus. Okay, so it goes up like that. Now, when we're reading volumetric glassware, for fixed volume glassware, we ensure that the bottom of the meniscus is touching the enameled or etched ring on the glassware. Okay, the ring needs to be level when we're looking at it as well. If not, we start to get gravitational errors. So we can see here we've got the ring here. So this looks like an etched ring, and we can see here the meniscus is just going down, touching it, and then coming back up. Okay, so that's the perfect point that we want for our meniscus. The same is true for volumetric volumetric flasks and volumetric pipettes. We want that pipette, so that meniscus to just touch the line. Okay, that's where we read it from. For the variable volume glassware, the reading is taken from where the bottom of the meniscus is on the scale. And the measurement has to be read at the same level as the meniscus. So, for example, you can't hold the volumetric pipette above your head. It needs to be at eye level so that you don't get any parallax errors. Now, the other thing to be careful of is the way that the scale's read. It might be read downwards or it might be read upwards. So here we've got a scale that's read upwards. So we're going 10, 15, 20, 25, so on and so forth. Then we get 45, 50, 55, 45, 46, 47, 48. Okay. So once we get to, that's our measurement there. So 48 mils is in this particular volumetric glassware. Okay. If you're not paying attention, you might go 50, 51, 52, but it's not, because our scale in this one starts at the bottom. A different bit of glassware might start at the top. Okay, so just be very wary of which one's which. Okay, so what we're going to do now is a practical. We're going to be using some volumetric equipment. So basically what we're going to do when you come to class, you're going to be familiarizing yourself with how the volumetric glassware works. So we'll set up several burettes. You'll have to read their volumes. We'll also check your accuracy in using the volumetric pipettes. So what we're going to do is I'm going to get you to use volumetric pipettes to dispense certain volumes of liquids and seeing how accurate, how precise, and how repeatable your experiments are. And then if we've got time, we'll make a standard solution of potassium hydrogen phthalate using our volumetric flasks. And that is all for today. Thank you very much.